Hi there, Dr. Hema here again. In this tutorial we're going to look at factorising quadratics. The focus on this tutorial will be on monic quadratics, so that's the ones where the coefficient of x squared is equal to 1. We'll have a look at non-monic ones in a separate video. Okay, so the first thing we do whenever we're factorising is we need to look for and take out the highest common factor. So just looking at a couple of examples here. So the first one, we've got 3x squared plus 2x. The highest common factor of this is x. So we can take out x as a common factor. When we divide 3x squared by x, we're left with 3x. When we divide 2x by x, we're left with 2. And that's as far as we can go with that one. Okay, next one. This time I've got 5x cubed plus 15x. This time the highest common factor is 5 as a number, and the term here that's common is x. So it's going to be 5x as a common factor. So again, if we take 5x out as a common factor, dividing this term through by 5x, we're left with x squared. Dividing this term by 5x, we're left with 3. And again, at this stage, that's as far as we go. Now, notice here, we've got a term left inside, a quadratic left inside the brackets. In the next section, we'll look at possibilities where we can factorise this term. So I'm talking about this term here. Okay, last one. We've got 15x squared plus 5x plus 10. Looking at this particular case, the highest common factor is, look at that, this is divisible by 5, that's divisible by 5, that's divisible by 5. So the highest common factor is 5. So taking that as a common factor, 15x squared divided by 5 leaves us with 3x squared plus x plus 2. And again, as I said earlier, with this remaining expression inside, we'd then look at methods for factorising that one. Okay, but remember, first step, always look for a highest common factor. So, moving along. So the main method we have for factorising quadratics, or monic quadratics, is the sum and product method. So let's just have a look at a bit of theory first. So if we've got x plus p, x plus q, so imagine we've already factored a quadratic. If we work back the other way, expanding that out, so remember that factorising is really just the inverse or the reverse of expanding. So expanding this out, we've got x squared plus px plus qx plus p times q. Collecting our like terms, we've got p plus q times x, I'll bring that out as a common factor, plus pq. This is now the sum of p and q. This term here is the product of p and q. So what we should notice, and what we can say here, is that the sum of the two factors, okay, p and q, corresponds to or equals the coefficient of x. The product of the two factors equals the constant term. Alright, so putting that into practice, what does all that mean? Okay, so let's have a look at an example where we're going to use the sum and product method to factorise a quadratic. So given this example here, so we're looking for two numbers p and q, whose product is equal to 6, so P times Q equals 6, and whose sum is equal to 5. So what we can do here is write down the factors of 6. So we can have 1 and 6, or we can have 2 and 3. Now we're not going to write down 3 and 2 and 6 and 1 here because they're equivalent. Looking at the sum, 1 plus 6 is equal to 7, 2 plus 3 is equal to 5. That one's no good. That's the one we're after. Okay, because that number there matches up with that number there. Okay, so putting this together, we end up with x plus 2, x plus 3 as our factorisation. That's all we need to do with that one. We're done. Okay, second example. We've got 3 lots of x squared plus 9x take 30. Now you notice not yet a monic quadratic because we've got the 3 out the front. Okay, so it's non-monic. But what we can do here, remember, first step, always look for a highest common factor. In this case, highest common factor is 3. So let's take that out as a factor. X squared plus 3x minus 10. So that means we want to factorise this stuff inside the brackets. So the product of our factors is minus 10, and the sum, oops, let's just get rid of that. We want the sum to equal 3. So again, we look for our factors of minus 10. So we can have minus 1 and 10, which adding those together, we get 9. No good, too high. Next one, minus 2 and 5. Minus 2 plus 5 is 3, which matches up with this number here. So tick, that's the one we want. So now factorise that, leave 3 out the front. Factorise that as x take 2, x plus 5. And again, we're done. One more. This time I'll look at an expression with a negative coefficient of x squared. So again, the first thing we want to do for highest common factor, in this case the highest common factor is minus 1. So we bring the minus out the front, we're left with x squared plus 10x take 12. So our product is minus 12. Again, go through the process. So factors of minus 12, we have minus 1 and 12. The sum is 11, no good. Minus 2 and, oh, what have I done here? Sorry. Let's tidy that up. Should be looking at 24. It should be 24 there. Okay, apologies for that. So we've got minus 1 and 24, sum of that is 23, minus 1 and positive 12, sum of that is 10, that's the one we're after. So that's going to equal minus x squared, again, don't need that there, factorising it, so it's going to be x take 2, x plus 12. Done. Okay. So maybe just stop there, pause the video for a bit, practice a few of these basic sum and product methods. Right, a couple of special cases. First one, difference of squares. So general rule is if you've got a squared minus b squared, we can factorise that as a minus b, a plus b. So an example, if I have x minus 49, remember, sorry, x squared minus 49, remember 49 is the same as 7 squared. So using this rule, we can then factorise that as x take 7, x plus 7. So that's done. Second example, 5x squared take 125. Highest common factor, again, we're always looking for highest common factor, is 5. So take that out the front. So we take the 5 out the front, minus 125 divided by 5 is minus 25. And now we've got difference of squares, so we can actually write that as x squared take 5 squared, which we can then factorise using the rule up the top there. Done. Okay, one last one. X squared take 20. Now, 20 is not a square number, so we can't just do like we did in the previous case. What we can do though is write 20 as the square root of 20 all squared. Now we've got it in the difference of squares form. So using our rule at the top there, we can then write that as x take square root of 20 times x plus square root of 20. Okay, last one. Perfect squares. So perfect squares, x squared plus 2ax plus x a squared can be factorised into x plus a all squared. The other form, x squared take 2ax plus a squared, can be represented as x take a squared. Okay, a couple of rules there. So using those with an example, if we have x squared plus 8x plus 16, notice now this number here is equal to 2 times 4. That number is equal to 4 squared. So using our rule, that is now equal to x plus 4 all squared. Done. Okay, that's all we need to do for those perfect squares. Second example, slightly harder example. 3x squared plus 36x plus 108. Again, highest common factor is 3. So dividing that all by 3, we get 3 times x squared plus 12x plus 36. Now looking inside the brackets, 12 is just the same as 2 times 6, 36 is 6 squared. So we can now write that as 3x plus 6 all squared. Okay, so that's basically a bit of a rundown on factorising monic quadratics with a couple of special cases, difference of squares and perfect squares. Alright folks, so have a practice at those. Again, if you need to, rewind, pause the video. Plenty of practice. Hopefully you'll get the hang of these. Alright, see you next time folks.